We just introduced the product rule and quotient rule, but even though just because we have a function that is the product of two functions or quotient of two functions, the product rule and quotient rule might be more complicated than what we need in order to take that derivative. So in this first match problem, that's what we want to take a look at. So we want to use two different methods to differentiate 3x cubed times 2x squared minus 3x plus 1. So the way we would break this up would be to look at this as one function, 3x cubed, times a second function, 2x squared minus 3x plus 1. So we have the product of two functions. So first thing to assume would be that the product rule would be our best bet to take here. But we'll actually have two different methods for solving a problem like this. The first method that we'll look at is without using the product rule at all. So without using the product rule at all, the first thing that we'd want to do is just rewrite this function f of x by taking 3x cubed and distributing it through all three of those terms. So that would give us 6x to the fifth minus 9x to the fourth plus 3x cubed. So we started off with the product of two functions, but distributing that through without using any calculus, just going back to algebra skills, we can distribute that through to get now a more simplified function, which now we can differentiate, hopefully very quickly at this point. So this is just three different power functions. So this is going to be 30x to the fourth minus 36x cubed plus 9x squared. And that's our final derivative. We're done. So even though we just spent time introducing the product rule, in some cases, if we can just distribute through, if we can somehow simplify or manipulate our function to go back to just using simpler methods, we absolutely want to do that. So as a second method, we want to look at differentiating this using the product rule. For one, to show how taking a different approach is going to lead us to the same final answer, and two, just to demonstrate how this product rule works. There will be cases where there's no getting around the product rule. We'll see some examples of those. In this case, we did have a way around it by distributing that through. In other cases, though, there won't be any other option for us. So we have our function f of x times 3, which is 3x cubed times 2x squared minus 3x plus 1. So we've got our two functions. So the derivative of this function, using the product rule, will be 3x cubed. So the derivative of our first function times the second function plus the first function times the derivative of the second function. So now what we can do is just differentiate 3x cubed and differentiate 2x squared minus 3x plus 1. So this will give us 9x squared times 2x squared minus 3x plus 1 plus 3x cubed, and then times the derivative of that second function. So we get 4x minus 3. So now we can take the 9x squared, distribute it through, take the 3x cubed, distribute that through, which will give us 18x to the fourth minus 27x cubed plus 9x squared plus 12x to the fourth minus 9x cubed. And then simplifying and combining our like terms, this will give us 30x to the fourth minus 36x cubed plus 9x squared. So in this case, this second approach using the product rule was more complicated, required more steps along the way. So in cases where we can simply distribute through, expand out, do something to simplify or manipulate that original expression, we might be able to find our derivative more simply. But if you can't pick up on how to do that simplification, or if you just missed that step, the product rule would get you to exactly that same solution. So in both cases, we're coming up with exactly the same answer.